Hello and welcome to another ramble with me. We are busy with IEB May 2025 paper 1 and today we're looking at question 6b. So the letters of the word meerkat are randomly arranged, so immediately take notice of the double E there. That does introduce some interesting dynamics, and I think that's the only repeated letter, so cool. In how many ways can the letters be arranged? So, for example, if you just had a word like cat, right, where all the letters are unique, then in counting how many different ways the letters can be arranged to create unique words or unique sequences, then we would have three options for the first slot, two options for the next one, and then for the last slot you're just left with one letter to pick from. So that would be 3 times 2 times 1, which is equal to 6. However, when we have a repetition, so if we had, for example, CCT instead of cat, so the starting point is that yes, if you're to think of each of these as little Scrabble letter blocks, for the first letter you do have 3 blocks that you could choose from. You've got 2 C's and 1 T, and then for the next slot you only have 2 letters, 2 blocks left to choose from. I think they're called tiles, right? And then for the last letter you have 1 tile left. So then indeed there are 6 on paper. There are 6 sequences for the tiles, but you need to bear in mind that so if we're to label this as C1 and C2, what we are counting here is that you could pick C1 first and then C2 and then a T, or you could pick the C2 first and then a C1 and then a T, right? So these are technically counting as 2 separate sequences, but when you look at the word that they create, right, the sequence isn't actually unique, because at the end of the day both of these just look like CCT. We don't actually care that you picked the second C first and then the first one, or the first C and then the second one, you know what I mean? So when we deal with sequences like this, where it doesn't, so these E's don't actually count as 2 distinct things, they're just E's, then we need to consider that we've possibly counted duplicates in this count, in this naive count. So for each sequence that is possible, we need to account for the fact that it could be C1 first and then C2, or it could be C2 first and then C1. So the way that we do that in this case would be to say, yes, there are 6 sequences of tiles possible, but in terms of how many words are possible, I need to divide that by 2. What do I mean by that? It means that for every word that is possible, there's 2 different ways that I could create that word. I could create it by picking C1 and then C2, or by picking C2 and then C1. So that's why we have to halve this number to find the actual number of words that are possible. So bringing this back to the problem at hand, right, in how many ways can the letters be arranged? We have 7 letters in total here, or 7 tiles, so technically 7 factorial, right? 7 options for the first slot, 6 options for the next one, etc., 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 until we get to the last one where there's just 1 tile left in the Scrabble bag. But now, because of the repeated E, we need to halve the count, because for every word, so let's just say for meerkat, it could be created by M, E1, E2, RKAT, or M, E2, E1, RK80. So every word has two possible ways that it could be created. So in actual fact, we don't have 7 factorial words. We only have half that number of words. And I think that would be 2,520. Right. Next up, what is the probability that the first letter is E and the last letter is E? So we have here E and then 5 other letters here and then another E at the end here. So what that would mean is for my second slot, we only have 5 tiles that we can draw, and thankfully they're all unique. And then we've got 4 options for the next one, 3, and then 2, and then 1. So there are 5 factorial words that begin with E and end with E. And we said that the total number of words that are possible is 2,520. So yeah, no, I don't know what that is off the top of my head. 5, where's the factorial? Oh, there we go. Divided by 2,520, and that is 1 out of 21. Not a very big chance. Right. I am happy with that. Then the last one, what is the probability that the 2 E's will be next to each other? So in this case, instead of thinking of the E's as separate things, I'm going to think of the M as its own tile, the R, the K, the A, the T, and then the 2 E's can travel together. Right? And so in how many ways can I arrange these entities, which is now not 7 things, but actually 6 things. 1, 2, 3, 4, 5, and then this thing, because we can't separate them. So that would be, okay, I could have the M, and then the E's could come here, and then the R, the K, the A, the T, or I could have M, and then the R, and then the group of E's, and then the K, and then the T, and then the A, whatever, right? So that's the idea. So in how many ways can these 6 things be arranged? Well, again, we count how many options do we have per slot. So for the first slot, we have 6 options, 5, 4, 3, 2, 1. So there's 6 factorial ways that these E's can be together in whatever word we create. And the total number of words possible is 2,520. And remember, we don't need to do any more fancy maths, like what if this E comes before this E? It doesn't matter, because to us, when we read the word, we're just going to see 2 E's together. Unlike if these letters were different. So if this was a P and an E, for example, and the question was in how many words would we have the P and the E together? So the P could be before the E, or the E could be before the P. Then we would have to consider that, okay, within this group, there's always going to be 2 ways that these 2 can appear different to the reader. I'm not explaining this well, but yeah, this is how I will gauge appetite for more content. Let me know if you want a clearer explanation. So in this case, the chances that the E's are together in any given word that we generate from these 7 letters is 2 out of 7. Right. What is going to be devastating is going to be to look at the memo and find that my answers are all wrong. Let's have a look. So first up, we have 2520 is correct. Next one, the answer is indeed 1 out of 21. And then lastly, we have 2 out of 7. So yes, you are officially fully within your rights to ask for me to give a clearer explanation, because at least I won't be explaining the wrong thing. So thanks for hanging around, and let's catch up another time.